right, good afternoon, everyone. I hope you all are having a great Friday today. So we're going to start off with an in-person presentation from Maxwell and Leslie. So they'll go ahead and begin. What we'll do this time, kind of like we've done in the past, we've got another group going to present virtually. So they're going to present via Teams. I think it'll work out best if we do an in-person discussion for the people presenting in person. That'll be worth 8 points on exam 3. And then if you're watching virtually, if you participate in the virtual discussion by speaking to the questions from, I believe it's Colby and Bryce today, is that right? I'm probably right. If not, whoever's presenting on.
Yes, sir. It's us.
Yeah. So, certainly, I encourage you to participate on that as well. So, like I said, just to kind of keep the discussion as few problems as possible from technological perspective. I think that makes the most sense. So with that, I'm going to go ahead and pass it over to Maxwell and Leslie, and they're going to go ahead and start off. Watch that.
Okay, my name is Maxwell Perkins, and this is
Leslie Smith.
And our presentation is on data normalization. It's a different type of data modeling, but it's very similar to an ERD. So, the next slide. I'm going to get you your points early. Okay, so can anyone explain this quote for me? When making a list, check it twice. 8 bonus points. Have you ever heard of Santa Claus? Okay, so data normalization is very similar to an ERD. They both share the goal of a well-formed, high-fidelity model. And we don't normally use normalization, but the way to use it is to create your ERD and then cross-check it with normalization to make sure that it is a high-fidelity model. And we got here the 5 goals. There are 5 normal forms to normalization, and it is a good way to point out fallacies. Because if you don't fit all these forms, you're going to have insert anomalies, you have update anomalies, and you have delete. And it's often equated to a Russian doll forms, and then each connected to each other. And the smallest form is first normal form. Next slide. Here are the 5 normal forms. They're just simple ones. And we created a few that we will show why they have 5 normal forms. So here's the nation entity. The nation entity violates the first normal form because the first normal form states that all attributes of the table must have single valued rows, must be single valued. So a nation can have multiple cities. So in this table, city would have tons of individual data points in one row.
And then for the state entity, that's the second normal form. We need for the city population won't necessarily be an attribute of state ID, which the attributes have to be codependent on the primary key for the entity. So city population be going for, say, like the city entity.
States that the entities, the attributes must be reliant on the primary key. Can't be inversely dependent on the key. So in this example, household is applied to city ID. It depends on city ID. Household members is dependent on household. So since it is dependent on household is dependent on city ID. Technically, household members is dependent on city ID, but it doesn't work for.
And for the fourth norm reform, we did for person and person, they can be like ambiguous. They can have like job and or school. So we wanted to like break that one down as well, make it to where they have like a certain job or go to a certain school, and where two people can make it where two people won't have to like go to the same job.
Got this normal form example as I can find a suitable example. This normal form, here's a relational assignment, and this normal form states that relational assignments, when possible, should be broken into different tables. So to fix this example, break this up into consultant ID, and firm ID would have, they would all have their own table, and would be relational.
And for our case study, we decided to Facebook. So pretty sure we all know what Facebook is. Largest social media platform in the world with roughly 6.5 billion users per month, active users. Most of their revenue comes from ads. 98.5% comes from ads. So say they have like an outage, that's pretty much all their revenue that's gone. And we can equate an outage to say if they have normalization issues within their databases. So if they have normalization issues within their database, they won't be getting all their revenue. They'll have to off the train of thought. Yeah, say if they have like normalization issues, they won't be able to like update their databases and everything, which causes problems within their databases and everything. So they'll lose most of their revenue, and they get a solid 190 million per day. There was an outage back in March of 2019, which cost them about 6.5 million per hour, and it was they were out for 14 hours, I believe. And that's like Facebook, Instagram, WhatsApp, Facebook messaging, all four of those were completely out. So they lost most of their money. And if they have all the normalization issues, we can equate that as it'll be roughly $7.9 million per hour that they would lose if they have the normalization issues.
Here's our second chart about their growing advertising revenue throughout the last couple of years. So we're going to start off with our discussion questions. Why should our databases fit normalization standards, and what happens when they don't? Anyone like to answer these?
Anybody on Teams?
Yeah, I'll answer if no one else will. So the first question, it's very important that when we have a database that we're not repeating information. If we're repeating information, we're wasting money. If you like to waste money, you can always bribe your instructor. Kidding. I shouldn't make jokes like that when I record it anyway. We don't want to waste money. We don't want to waste process power. We don't want to have a system that does not meet the requirements for what we have financially. Especially this is important if we're going to be a cost leadership firm. We don't want to have a case where we're spending more money than is needed. If we are, then that means that we can certainly cut back and offer the same level of service. So we wouldn't be losing anything to have this. You also think about the maintenance cost of using a normalized database. If you have a database that has just a wacky model and you bring in new employees, you've got to train them on understanding your wacky model. If you're using normalization, very easy, very concise to understand. So I think there could be a lot of problems for not following those standards. Anyone want to add anything to that?
Yeah, I mean, like, of course, business, first things first, got to make money. If you waste money, you ain't making money.
Facebook makes most of the money out of the users. If they do not meet these standards, and they have issues with their profitable.
For our second question, we have, from a financial perspective, do you think it is worth it to take the time to normalize your database, or should time be spent somewhere else?
I'll answer.
Yeah, you can look at it like an investment. Like, you don't want to have to just keep going back and putting more money into it, and in the long run, losing money.
It's worth it. Cross check your answer. In ERD, it's worth it. Check to make sure. You just like spend.
I think cross-check means like having an essay, like you could typing it up and you didn't really correct punctuation or incorrect spelling, and then you see.
Yeah. I mean, you can look at normalization, these normalization forms.
I mean, no, you probably did something wrong. Usually syntax there.
Yeah.
Yeah, let me add something here. I think it really depends on the second question. What kind of scale are we talking? We're Facebook, and we have one column that has repeated information in it. You know, you may be talking about gigabytes and gigabytes worth of, possibly terabytes worth of stuff, you know, and you don't just store that information one time. You know, you certainly have at minimum one copy of it, probably 3 or 4 if we're talking Facebook. You know, it's very costly to have that. You know, you're talking buying enterprise drives, you know, for a couple terabytes. You know, you're looking at probably a couple $1,000 when you factor in all the redundancies you have to do. You factor in the maintenance cost of everything. I think you're certainly not looking at something where it makes sense to not normalize. However, if you're a small firm, and let's say your one column has, you know, I don't know, a couple hundred values in it, you know, from a financial perspective, it certainly does not make sense to spend hours of your time where that may be, say, 10% of the labor for your week. You know, you can certainly spend that, and you get back just a minuscule amount. So the scale is very important in this conversation, to recognize what's the scale of the amount of data, and is it feasible for us to, you know, remove it? Is there a reason to not remove it? It could be easier to work with if we don't do that. So I don't think there's going to be one single answer. Certainly in most cases, when we're forming the data model, it's going to make sense to have it in a normalized approach. But if it's already there, it could make sense to keep it as is.
Larger firm, don't normalize your data, then that's more money that you're missing out. But you could have just prevented by check over it. Okay, so for a final discussion, do technologies like MySQL Workbench let you know if your data now is
Here, you want to answer?
I do want to.
Disgusting
The real
question, yeah.
question is,
So I'll jump in here. I mean, it's not going to tell you your data meets 3 normal form, 4 normal. It does not have that capability. It can tell you if you have a syntax problem. It can tell you if something, you know, I mean, but a lot of it's going to have to be your intuition. So you, the database administrator, you have to look at the model and you say, does this have redundant information? Yes or no. You know, it can certainly highlight issues with data types. It can highlight a lot of issues with how you define something, but it can't really tell you which form something is in, because that's really more of a conceptual thing. You know, you look at a diagram and you can immediately tell. But to be able to do that with an algorithm of some kind, it could be done, but I don't think that they would. And you know, the value that it would take to derive an algorithm to tell whether information is repeated or not, will be pretty costly. And is this something that will provide enough people value to justify work on the open source community doing it? Probably not. So I would say that this is really a case where you, the database administrator, look at this and you make your best judgment call as to which normal form it should be in.
So you could probably just get your, you want to know if it's in normal form. Try to test inserting data, try to test taking out data, update your data, and if you find any anomaly, something is wrong.
Anything to add?
All right, good job, guys. All right, so now I'm going to go ahead and stop sharing the screen. I'm going to pass it over to Bryce and Colby, and they're going to go ahead and present. So one of you
Okay.
two, I don't care which, just make sure you share your screen.
There we go. Can everybody see that? Or
I don't think so.
Oh,
No.
crap. Okay, there we go.
Yeah, we got it now.
Okay. Let me turn. Okay. So, my name's Colby Stroop, and then my partner is.
Hey, I'm Bryce.
All right, there you go. And we're going to be also going over Chapter 8, Normalization and other data modeling methods. I added in some nice transitions to make it look pretty. So, normalization is a process that essentially allows you to weed out redundant data from a database. So it just lets you get out, makes it just more efficient and just have less issues with being able to read and interpret all the data within a database. Then nice little transition. You want to hit this one up, Bryce?
Yeah, sorry, there's just a bit of a delay.
Oh, my bad.
All right, so one of the ways that we can normalize data is with something called functional dependency. And what that means is if you have one table that determines the attributes of a second table, that first one is functionally dependent. So we can use this to eliminate a bunch of redundancy. For example, if we have 5 tables, 3 of which having pretty much the same type of data, we can reduce that to a total of 3 tables with this method of normalization. normalization.
Oops. Then we also, on top of that, have several levels of normalization. As you go down the redundancy, as you can see at the first level, as you keep going down, the redundancy goes down. But as you go up, you also have more tables. The number of tables goes up. The preferred amount, it is generally preferred to stick around the third normal form and Boyce Codd normal form. Those are kind of, I guess, the standard of what you want to try to shoot for, because just makes everything nice. Then we have an entity relationship model. It's kind of like our entity relationship diagrams we've been working on, but just laid out differently. Personally, I prefer the entity relationship diagrams because they seem easier to read. But as you can see here, each rectangle in it is an entity, and the entities in this model here is a professor, a student, and a course. And the diamonds are the actions between them, and the ovals are the attributes. So you can see that the professor has 3 attributes of a salary, the department A, and tenure. That's kind of a brief talk about that. I like the little bird.
So believe it or not, data normalization is actually pretty normal here with most industries. So we had a difficult time finding specific examples of companies publishing data on how they use normalization to apply it to this presentation. So we went ahead and made our own, fictional company just to simplify it and make everything easier to understand. We created S&C Enterprises, and blue is everything before we normalize our data, and then teal is everything after. And we did it this way to make it as easy to understand as possible instead of trying to use graphs provided by a different company. This is just the most basic way to show how normalization affects our time wasted, our revenue, our customer retention, and the efficiency.
As you can see, afterwards we are making quite a large difference in revenue. So you can buy shares of our stock, right now. Probably give yourself a real good boost. Now we're gonna move on to the Q&A section of the presentation. This goes out to everybody out there. What is a pro of normalizing your data from a financial perspective? For, was it 8 points?
I have an answer.
Okay.
This is Tate, by the way.
Hey, Tate.
Pro would be, your revenue would go up. just by that graph, if your efficiency goes up and your time wasted goes down, that will make your revenue go up because you're not just going, figuring out the same information over and over.
Mm-hmm. Just a real boon for your company from a financial standpoint.
Yeah.
Anybody else have any input they want to try?
Yeah, I think like we talked about in the last discussion, it's all about reducing redundancy. If you can reduce the amount of data you have to store, you'll certainly be able to save money, assuming you have the scale to justify it. If you're a small firm and you only have a handful of employees, it may not make any sense at all to do this. It may make it more costly to work with. But if you're a multinational firm, it certainly will be beneficial to not repeat your information inside the database.
Okay. Then what is a con of?
I got this. This is Jonathan Bishop, by the way. The con of financially perspective of normalizing it would be kind of like what Professor just said. It's like if it's a small business and stuff, it might be more costly because you might have to add more entities, and it's just going to be more data taken up by those entities trying to reduce redundancy. When you could just leave it alone, and it'd probably be fine for a small business or something.
Yeah, I was thinking something along those same lines. Whenever we made this. Anybody else want to do anything or say anything else about it, or don't want to cut anybody off?
So if this is Justin Master speaking, so like if there were like two small companies like combining, like saying if they were like, say one company bought the other one, would trying to like combine those systems be a con, do you think?
It would be like if they're using 2 different standards, that would be a big hassle for them to combine. It just depends on the scale and then how they were managing their data before the acquisition.
Oh, okay. Thank you.
Yeah, and let me jump in here if I can. So in this case, it'd be very important to have a data dictionary. At some point in the course, probably I'm assuming maybe chapter 9 or 10, we're going to talk about what a data dictionary is. But basically, as the name implies, it is broken down by each table that you have inside the database, gives a description of each column, gives a column name, gives the data type of the column. And if you look at those two documents for two firms that are going to combine, you'll be able to have some idea of which ones kind of correspond to the others, and you'll be able to use statements like select into and combine the data in that way. It wouldn't be terribly difficult. It'd certainly be feasible to accomplish that, I would say.
Okay. Move on to the next one. What is a pro of normalizing your data from a technological perspective?
So I'll jump in here if no one else wants to. Basically, from a technological perspective, we're able to get quicker answers to things. If we have a smaller database, we can certainly run queries quicker. We could certainly have faster answers. We could have just overall a better user experience because you're not having to wait 5 minutes to return one value from something. If you have a small database, then it has ample processing associated with it. You certainly won't have any issues in terms of using the database, getting the information you need, inputting information into it. Should just be a lot quicker.
Okay. Wow. What would be a con of normalizing your data from a technological perspective?
Just Masters here. A con would be like if it's a large enough company where it's like say it's like one of Warren Buffett's companies and there's multiple departments trying to get information from each department, like to cross and like make sure information matches up could be an issue.
Yeah. Could be a real big hassle, real hard to manage. Does anybody else want to add anything to it or try and get everybody all these points we can? Okay, well, we'll go on to the next one. Now we're going to move on to a people perspective. What would be a pro of normalizing your data from a people perspective?
This is Jonathan Bishop again. One pro from a people perspective would be, I guess, like if a person like not familiar with technology goes on and looks at the database, it'd be easier for them to understand what's going on. If you produce a lot of redundancy, it's not that hard to look at for someone that's not used to databases and all that kind of stuff.
Or at least thinking something similar along the lines of just like say your workers in general who have to look and interpret the data. Like having it as simple as possible would help them be able to use it more efficiently, be able to understand it easier. It's what we were thinking, at least.
It also means you don't have to have as many skilled workers, at least to manage, the baseline stuff. So it can help lower how much you spend on your employees.
Okay. What would be a con of normalizing your data from a people's perspective?
Yeah, I'll jump in here again. So, if you have just a standard big table and it has every single thing you need to know for your firm, let's say we're a fast food restaurant and we have just a huge Excel spreadsheet. And it has stuff like what orders we had, it has our sales for the day, just everything inside of one place. And it's all in one big table. That's very easy for someone to come in and start adding in new records. Now, is it very easy to get meaningful information from that? Maybe not as much, but it certainly is easy to use. So when we think about this from a usability perspective, I think it's fair to say that a table that's inside a first normal form, or even zero normal form, where it doesn't have any normalization at all, can be a lot easier to just pick up and grasp than when you have something inside a third normal form where you have different relationships present. If you talk to someone who's not taken a database class or is not familiar with database management principles, it can be kind of difficult to understand what these relationships mean. You think about a recursive relationship. It can be difficult to understand, even if you do understand the principles behind recursive relationship, it can still be challenging to grasp that from a conceptual perspective. So I think that certainly that could be a con from looking at this from the people's perspective. Especially if you consider, fast food restaurant, you have to consider who the users are going to be. So that's certainly something you'd want to keep in mind, that you're tailoring the data model to the people who are going to be inputting the information, getting information from it. Those are all important considerations to make.
I believe that was our last one. Yep, that was all we had.
All right, well, good job, guys. Thanks for coming. For those of you who participated, thank you. For those of you who attended, thank you as well. It's still good to attend. I hope you all have a great weekend. I will see you all Monday. Oh, and don't forget, before we all go, if you're going to submit the exam corrections, they're due at 11:59 p.m. Tonight. So make sure that you submit those, and I'll make sure to apply them to your exam. No homework this week. Next week, I'll probably post a homework assignment. I just figure with the exam this week and with the exam corrections, give you guys somewhat of a break there. Any other questions for me? Like I say, I hope you all have a great weekend.